Page 23, continuing on with whatever this was. L4, I think it was L4. What was this?
Can I have your calculator, please?
Yeah. I don't know what this is doing here. This is not. Okay. I thought I learned the other one.
No, I gave it back to you.
I gave it back to me. Of course you did too. That's another random one, by the way. Oh no, maybe it is the one that I had. Okay, so we're on page 23. So we're continuing on with L4, translations and stretches of trigonometric functions. So this could help. Definitely, some people happen to have done trig models in their IA. And so this kind of thing is how you would explain the maths behind it. So just reminding you of all this kind of stuff. Oh no, it was this page. Is good. So the A is the amplitude. If you kind of measure like from the halfway from the top to the bottom vertically, then that's your amplitude. So the amplitude of this graph would be like the length from here to here, half. The amplitude of this graph would be the length from here to the top, half. So that's your amplitude. The B isn't the period. The common error is people say that B is a period, but B is not the period. It's used to find the period. Because if it's in radians, it's 2 pi over B is your period. And if it's in degrees, it's 360 over B is your period. So remember we were talking about things last week like vertical stretch and horizontal stretch. A, the amplitude is, think of it as like the vertical stretch, like from functions. And the period is related to the horizontal stretch. It helps you, it informs you of the horizontal stretch. Because the vertical stretch scale factor is A normally, and the horizontal stretch scale factor is the reciprocal of B, like 1 over B. And now we introduce C and D, like the horizontal and vertical translations. So remember x minus C? So if it was x minus 2 in the brackets, how has it moved left or right if it was x minus 2?
Ooh, to the right.
Yeah, to the right, exactly.
But if it was in the vector, whatever it says what it is.
Yes, exactly. Good point. So yeah, if it's in the function like this and it's in a bracket, it's a horizontal translation, and it's the opposite of what you see. So if they had x plus 3, then it's gone to the left 3 units. Whereas the vertical shift is exactly what you see. So if it's plus 4, it's shifted up 4. If it's minus 4, it's shifted down 4. So considering this, find the equations of the following graph. So we did the first one. And then, first of all, we looked at them and decided, are they sine or closer to sine or cos? This one sort of starts at the centre, so we went with sine. This one we went with cos because it is an exact cos graph. It starts at the top. This one is a cos because it starts at the top, at the maximum. And this one you could have said sine or cos. Like if you thought of it as being horizontally shifted this many units, then it would be a cos. If you thought of it as being shifted this many units, it would be a sine. So we went with sine, I think, because sine was the closest one. Let's shift that far to get to sine, or that far to get to cos. So we went with sine as being ours. So we first of all tried to pick the general function. Apparently with modelling, there's a general rule. If you're modelling for an assignment, the general rule is make it a sine graph for some reason. The general rule is go with sine when you're modelling real world data. And then you just shift it, because a sine graph is just a cos graph that's been shifted horizontally.
So then why is it a sine graph?
Indeed.
That's my question. If the general rule is to start with a sine graph and then shift.
Yeah.
Why
I think
isn't it
the math gods just said just go with that.
Math goals, I don't even think they exist.
You know, when sometimes people are just like, we need a rule to go with, so they made it.
Yeah, what are the names of math gods?
Solvo, Factorido, Simplifia. We have a proper thing going on with Year 7. And one day we made a shrine. Solvo is like a cloud. He's got no hair.
Oh, this is like Solvo, like solve an equation.
Yes.
Oh my
So
God.
Solvo, he's got a,
She more of a math.
because it's a he. So if it ends in an A. Solvo's got a lazy eye.
Right here.
Creating Solvo in my image. So Solvo, he looks like this,
You know the way what was on my story last night? Did you know what was on my story last night?
and he's got
It was my fifth.
one eye here, and he's got a cock eye here, and a little smile, and that's it. And I think Factorita has brackets for eyes. And I think they made her a square with arms or something like that. And then there was also Expandia. Oh no, maybe Expandia had the brackets for eyes.
Is that your recording?
Yes. So that's Solvo, and some of them like Solvo, but some of them hate Solvo. Because they found solving hard. You know, when you're in year 7, the equations are so easy. You could just say 3x equals 9. X, of course, it's 3.
Yeah.
Whereas they find it painful to show all the steps because I said, Solvo, look, it's thunder outside. It's made Solvo angry.
I remember thinking that.
And one of them got so angry she wrote on their leg during the lesson, I hate the algebra gods.
Wait, so what does Factorita look like?
I can't remember. I think Factorita is kind of like a weird, like, you know, like kind of shape. They kind of invented the other ones. I think I came up with Solvo and they made the other one. There's a whole shrine of algebra gods.
Solvo's such a nice shape, though.
Yeah, Solvo's kind of the alpha god.
It should have been a triangle with its Factorita.
Yeah, Factorita.
So back to here. So the one we did this one. It's a sine graph. So who could be the trig sine graph? Who could be the trig algebra god? Triggy. Okay, so Triggy has decided go with sine. If in doubt, like it's not, so then like so if cos fits perfectly, go with cos. But if it's one of these kind of half things, sometimes just generally go with sine. When it's kind of like it could be cos, it could be sine. The general thing is they say go with sine when you're modeling real world data, but they don't really care that much. So Triggy said. So we found our amplitude because remember it's sine. We need to find the value of A, which is the amplitude. So the nice thing is the principal axis hadn't been shifted. The principal axis was right here. So it means that the value of D was 0. So notice that if the principal axis is still through the center, at the x-axis, then the D is just 0. So that's why we didn't write a D. The amplitude of a regular sine graph is 1, goes out like this. But this one was up to 2 and down to -2, so its amplitude is 2. And it's not flipped upside down, so it's just +2. Sine. How do we find that B is 1/3? How on earth did we do that? We notice that a full period is from here to here. It's not from here to here. A full period is just literally one cycle, and then it repeats itself. So a full period is from here to here. So what number was that? 1080. So the period we wrote is equal to 1080. And then we notice it's in degrees. So use the period formula for degrees, not 2 pi. So 1080. So 360 over B equals 1080. And then rearrange to solve for B. We just did, you could think of it as times the B over here, divide both sides by 1080, and then you get this thing. Or some people just think of swap those two over. And then you get 1/3. So you could have written it as 2 sine 1/3 x. Or you could have written it as 2 sine x over 3, because 1/3 x is the same as x over 3. Both are just as good as each other. These ones, you might notice that there is a D. So I know there's not a D here, because it went up to 4 and went down to 4. So where's the principal axis for this one? Still just through the center. So the principal axis hasn't shifted, so what does that tell us about our D?
It's 0.
Yes, good. So I didn't write that on the other one, so maybe I didn't rush. So let's make a quick note of on this one. So principal, I'll write over solo. Principal axis still at y equals 0. So D equals 0. So there's been no vertical shift. So if the principal axis is still on the x-axis, then the D is 0. Is the D is going to be 0 for this green one? No. And what about this one, the last one? No, yeah. So these kind of look like, is the x-axis at the halfway point? No, it's not the halfway point. Well noted. So principal axis thingamajiggy. So what's for A?
For which one of these?
Yeah, we're doing cos this time. Good. Well done. How did you get 4, Sarah? That's correct. Good, exactly, yeah. The full height of the graph is 8. Remember the amplitude is only half of that. So it goes up to 4 and down to -4. So A equals 4. If you want to make a note from here. A equals 4. It's a Coles graph, so it starts at the right point. Coles graphs start at the maximum. What's its period? How did you get that, Sarah? Ah!
Oh man.
Okay. How did open all these documents? Close. I'll close that one too because it'll keep opening. Come on, just close. Ah, cancel. Save. Okay. So, Sarah, back to you. How did you get 120 as being the period? And it's correct. Yeah, good. And sometimes it takes a while for people to notice, like how long a cos does a cycle. So basically, it started at the maximum, went down, and it finished at the maximum. So the period is that length across there. Whereas for a sine, the period's when it hits 0 again here, but it's when it drops down and comes back up and hits 0. So that's the period for that one. And then Sarah noted that that's at 120. Does that mean our value of B is 120?
No.
And is our units in degrees or radians?
Degree.
Degrees, good. So we need to use the
Degree.
the degrees formula. Period equals 120. So you can write 360 over B equals 120, or solve it however you like. So how would we solve for B? So period's 120. Yeah, sorry, continue.
360 divided by 120.
Good, yeah, 360 divided by 120, which equals 3. So we've got our formula now. Our formula is
Y equals
Yep.
4 cos 3, or is it 1 over 3?
no, you're right, 3. And notice sometimes they quite often put that in the brackets. Put it in brackets, the B. 4 cos 3. Some books don't put it in the brackets, but ours does. And I think in the IB exams they tend to put it in brackets. 4 cos 3x.
This is how I do
Is there any plus thing at the end?
No.
Nah, that's it, isn't it? Yeah. Because you could write +0 if you really wanted. There was no need to. 4 cos 3x. Yeah, so some people with their IAs have had to do things like this. They've looked at their data. So you try to work, first of all, where is the principal axis? Like, is it here? For most people, it's probably shifted up. So working out the principal axis, how far up or down the principal axis has moved, is what you do to work out the D value. And then I tend to look at I tend to mark it in, and then use it to work out the amplitude, and decide, do you want to go sine or cos first as well, and then use that, maybe mark in the invisible principal axis to work out the amplitude, and then I tend to look for a period. Sometimes when you're modelling, maybe if you modelled, you only went from here to here, so you might just have to be aware, therefore that would be a quarter of the way across the period, and so on. I'll just continue on.
Radians.
Ah, good, well noted. So how did you realise this one's in radians, Krista?
Because of the pi stuff.
Yeah, the pi stuff down here is an indication that we're in radians. Bella, what are you doing? Okay. So, Bella, could we work out our value of D on this green one? Yeah.
Do we just have to do the first things so like the A and stuff?
Oh, well, yeah, you could. But I want to know the D, just because I'm picking on you about the D. So,
Okay, but I thought we had to work out A and then we do the period first and then...
yeah, there's no rules about which order you go in.
What's the value? Oh, the principal axis.
Yeah, it's a vertical shift. Yeah, so how far up has a vertical? Yeah, good. How did you get that?
Because it's in halfway, not it's marked.
Well done, good. Exactly. It's marked, yep. So you could talk about the fact that the principal axis has shifted up 5 units. So D is 5. But yeah, there's no need to find B first. I just thought it was easy to work out. So D equals 5. You can work out A first. But sometimes notice that drawing in the principal axis sometimes helps you see the amplitude if you're struggling to see it. So drawing in the principal axis can help you to see the amplitude. If you want to.
It's 1.
It's 1, do you promise?
Yeah.
How do you know it's 1?
It's like, see that 6 minus 5 is equal to 1.
Yeah, exactly. So if you change it by 1 here, and that 1 there, that's good. So A is our 1.
It's like harder to try to explain that than like.
Actually, like I have eyes.
But imagine running that in IA, I have eyes. So everything else in they're being completely normal in the IA, except I have eyes. That's the explanation for the thing. What is the value of C out of interest? Just to remind you of the value of C is a possibility.
The value of C? What's C?
C is a horizontal shift.
The horizontal shift?
Yeah, there's nothing in the
I mean,
horizontal
if
shift.
it's a constant, then it hasn't horizontally shifted.
Yeah, 0. Who said 0? Chris, how did you get 0?
Because it hasn't
doesn't shift.
Yeah. Yeah, how do you know it hasn't
Because
shifted?
it's going to the rate of 2 pi.
And also, a closed graph starts at the maximum, yeah. Good point. So a closed graph starts at the maximum.
Oh, the horizontal shift, thinking of the horizontal
So it has a
shift.
shift, yeah, and this one starts at the maximum. Whereas this one, if you did cos, then it doesn't start at the maximum. So you might, maybe, I haven't pointed that out as cos starts at the maximum. So I haven't noted that before, so maybe we should put that in. C equals 0 is close theta starts at the max. So it's where the graph starts where it should. But we need to work out, what's the last thing? B. What's the period of this graph?
Is that a cos theta?
Yeah, so C equals 0 as cos theta starts at the max kind of thing, or the graph of cos theta is meant to start at the max. Whereas the graph of sine theta starts at the halfway point. So there's no horizontal shift. Did someone just say what the period was?
2 pi.
But that's good. How did you get 2 pi?
Because it's cycle 0 pi to 2 pi.
Because she has eyes.
Yes, I. So the
Wait,
period,
why does she? I don't know.
why does she like?
Who has us?
So can you just say that again? How did you get 2 pi as the period? Did you hear that, Krista?
No, it's probably in those times.
She asked me, sorry. What, third time, sorry, Sarah.
Wait, that wasn't my question. I knew that.
Oh, okay.
I'm not sure it's why.
So do we use 360 over b equals 2 pi?
No.
No. What do we use instead?
2 pi over b.
Yeah. Yeah. So what does b equal? Yeah, good. So 2 pi over 2 pi. So b equals 1. So our formula overall, what would we write?
Y equals cos bracket at no, never mind. Y equals cos x plus 5.
Yeah. That's true.
Yeah, doesn't make so many dots every day.
No, it just seems like so simple though, doesn't it? Because of all the ones. So notice because it's b is 1,
Yeah.
a is 1.
So sorry.
What did I write for my answer?
I
I just did it ages ago. No, I just did it ages ago. But I just didn't recall feeling like, oh, so nice and good. So it's not wrong if you wrote the ones, if you really want to write the ones, but it's just weird. So cos x plus 5, because we've got b equals 1, a equals 1.
Like that.
And it's a cosy graph. And all that stuff.
Oh, you used to do this.
Stella, for the fourth one, how much has the
I was just trying to
how much has the principal axis changed?
But it's not there today because it doesn't get 3%. Are we just talking about the one?
Yeah, so to work out the d, sort of try to think how much has the principal axis. The principal axis is normally the x-axis,
Yeah.
is a midway point.
Is it 1.2? 3.2. Negative 3.2.
Yeah, negative 3.2. Yeah, that's a 3-point negative.
It's not. It
Yeah.
does have negatives.
It barely has numbers. It can't even believe it.
Yeah, exactly. Yeah, I think it's meant to be 3.2, isn't it? Yeah. It's like
It's supposed to be negative 3.2.
Negative.
yeah. Yeah. Oh, yeah. So maybe I think I didn't snip it very well. Yeah, right. It needs to be negative. So the principal axis have shifted 3.2 units. So what's our d then? Negative 3.2. So the d is basically the equation of the principal axis. So the equation of the line of the invisible principal axis is 3.2. So that basically tells you the d, tells you how much it shifted from the x-axis. And we're doing I think we decided to go with sine. So we'll go with sine. Yeah, just because sine's the closest one. And the triggy says, when in doubt, go with sine. But also sine's the closest one, because notice it shifts just this much to get to sine, but it shifts this much to become a cos. So it does make sense to go with sine for this one.
Halfway between 81 and 27.
Cool, so what's the amplitude? Anyone want to suggest the A?
1.2. 3.2.
What is the amplitude? That's right. 6.4?
Yeah.
How did you get that, Tilly? Yeah, good. The distance from the principal axis, yeah. So it's 6.4, and it's sine, and it does go up, it doesn't go down first, so
They
it's
go down.
6.4. So, because it's like, so maybe you do that and write A equals 6.4, because it's 3.2 plus 3.2. 6.4, the distance from the... So see, drawing in the principal axis to start with sometimes makes it a bit easier. And then it makes it easy for you to see where the amplitude is and all that kind of stuff. Cool, so what about the C? What's our C going to be? Has it shifted left or right?
Right.
Right, cool. How much has it shifted?
27.
Did it? Has it shifted right?
No, it hasn't shifted at all.
Yes,
It
hasn't shifted at all.
No, that's such a lie.
Yeah, that's a good point.
It's shifted
Down.
to the...
If we're doing sine, it hasn't shifted at all.
No, if we're doing fine, it's not has to start at 0.
It's gonna start at 0.
Wait, what?
The horizontal shift.
Oh, no, it hasn't shifted.
Oh, not horizontal.
Yeah, that's a good point. So when I looked at this, and I said, oh, it's shifted.
Why
I
is
was
it
wrong.
y equals?
Sorry. So when I shifted, because that's the equation of the principal axis,
No.
which tells you the D.
I thought D. Okay, same.
Yeah, because remember, equation of a horizontal line is always y equals x. So that's a good point. When I was blathering on about like, oh, it's a sign that's shifted, I was saying it wrong because, as Tilly said, it has shifted from where the principal axis is. No, it hasn't shifted. It's not at the right spot. Okay, so I was looking from the x-axis, which is not the principal axis, so it actually hasn't shifted at all.
Oh, that's why you were thinking that.
Yeah, I don't know why I was thinking. That was wrong with me. My answers were right though, but that was no one else talking about it. Nice. So now the last thing is to work out our B. So first of all, maybe just write out what is the period equal to.
Period is a word.
Yeah. Is it someone?
No, it's not. It's invisible.
It doesn't tell us. That's why I need to know the halfway point between 81 and 27.
Yeah, so notice this one. So it goes across in quarters.
54.
54?
So do 26. No.
No. What's 27 between 54?
It's 54, so half of that is 27.
Half of that is 27, so they go up in increments of 27.
Yeah, so 81 plus 27 should be 108.
Hey, what are we talking about?
Yeah, because notice they go up in quarters. Like you know the unit circle, as we spin around the unit circle, it's a different quadrant. So from here to here is through quadrant 1. Here to here is through quadrant 2. Here to here is through quadrant 3. And here to here is through quadrant 4. So it actually splits into distinct
So it's 108.
quarters. So it'd be 108, yeah. Because 108 or 27 times 4.
I'm just gonna ignore this guy.
So see, so notice 27, 54, 81, 108.
Oh, I understand.
And it doesn't say anything about whether it's with those numbers, with those kind of numbers, sometimes you could say radian, sometimes you could say degrees. Maybe let's just go degrees, will we?
Yeah, definitely.
Yeah, 108 is sounding a bit degrees. So 360 over b equals 108. So what's our b equal to? 3 to third, is it? Yeah, so 3 to third, which you could 3.33 recurring is correct if you want to write in 3.3 recurring. So 3.3 recurring is correct. If that feels awkward to you to write into an equation though, as a b, you can write 10 over 3. Because 3.3 recurring is like 3 1/3, which is 10 over 3. So I wouldn't write sine 3 1/3 x, because that feels a bit weird. But I would write cos 3.3 recurring x maybe. But even better, I would write cos 10 over 3 x. Sine, yes, sorry, yes. So you're right. So y equals, what's our thingamajiggly?
4.
Yeah.
Sine.
Yeah.
3.3 x.
Yeah, or even better, I'd say the improper fraction just looks a bit cooler. Like 3.3 recurring you'd have to have, which feels a bit weird to write somewhere in there. So 10 thirds x or 10x over 3. 3 and a third x looks a bit too weird. 3.3 recurring x is the next less weird, and the least weird is 10 thirds x or 10x over 3.
And why would it have to do?
Subtract 3.
Have I missed something?
Yes.
Good, yeah. Minus 3.2. This one's got a d. That's not zero. It's got a d that's not zero. So the people that did trig modelling in their IA have this kind of stuff. They have to talk about the shift in the principal axis. They have to talk about finding the amplitude. They have to talk about how they found b using the period, and they have to talk about the horizontal translation, that kind of stuff. So they have to go on about this kind of thing, and give reasoning and all that kind of stuff.
That sucks.
Oh. Next page. Good. So a few little examples of some nice ones. I don't think they're too hard. I actually saw these from GCSE exams. Some nice one. Diagram shows a graph of a sine bx degrees for 0 to 90. Find the value of a and b.
A is due.
You are correct. Where's the principal axis this time, out of interest?
0.
Yeah, through 0, yep. So if it helps you, draw that in. There's our principal axis. It's a little invisible thing.
There it is.
So what's our value of a? You said already.
2.
Dose, good. 2. So, for your sake of your notes, you might
Equals quattro.
references to how you got
4.
it. Oh, how did you get that? What's that?
360 divided by 90.
Okay, yes, because it's degrees. So period equals 90. So 360 over b equals 90. So as we're saying, b equals 360 over 90. So b equals 4. So as I said, the most common boo-boo is people thinking that the period is the value of b. But the period is not the value of b. It informs you of the horizontal stretch because the reciprocal, related to the reciprocal of b. Next one. It's a nice one. So here they're saying use sine kind of thing. So they're forcing us to use sine and not cos, just because the questions that help you out and do it. So what does the fact that there's a number added in a bracket tell us about the graph? Good, yeah. Shifted vertically or horizontally? Horizontally, good. Where's our principal axis this time? I just like to practice.
0.
Yeah, good. So so what is our value of d out of interest?
0.
Good, yeah, because there's no horizontal shift, so d is 0.
Then it was a horizontal shift.
Oh, sorry, no, I was saying vertical, sorry, yeah. D, the principal axis is related to the vertical shift, sorry. Yep, so the value of d is 0 because there's no vertical shift. What's our a? 2, good. How did you? They're not very creative, are they? They have the same looking graphs. So a equals 2. Maybe let's write that up here. Well, just round notesies. Out of interest, what's our period? One day we'll get a new board. Okay, so period equals 360. How did you get 360? It's correct.
330
Plus 30 to 330.
Yeah, good. Right, it goes from 30 all the way to 330. So you might just want to note.
And then
Some people might look at that and go, oh, the period's 330 by mistake.
Yes,
So just keep an eye out for that. Equals 330 plus 30 equals 360. And so you've got 360 over b equals 360. So b equals obviously 360. It's fun, isn't it? So b So that's why, but notice you know that already, but we're just trying to prove why, that kind of thing. Because I noticed that my boo-boo is I'd maybe look at that and go, oh, the period's 230. I've got to add that little 30 in there too. How do we work out what the C is? or actually they're calling it B this time, but horizontal shift. I'll just call it C, but we'll put it in the equation as B. So where is does the sine graph normally start? Where is
There or so
Yeah.
is it negative 30?
Yeah. So it's shifted. So it's shifted 30 degrees left.
Oh, so we keep it as positive.
Yeah. So the bracket will be good. So it's shifted 30 degrees left. So it'll be x plus 30. Yes. And notice in here they defined it as x plus b. So is b 30 or minus 30?
30.
Yeah, 30. Yeah. So c equals 30, but we're calling it b in this thing for some reason. 30 degrees.
That's a tricky one.
They might not care if you put the degrees on the 30. So b
But
equals
if
30.
it was plus, we would write negative 30 because then it would add on make it minus.
Yeah, exactly. Yeah. So if it had shifted this way, we'd put negative 30 here. But when the general form is x minus c. But here they wrote x plus b, so we have to keep that in mind and go, oh, hang on, it shifted left. So in the real formula, it would have a plus 30 because it shifted left. They confuse us by making it not straight up.
But that's just confusing.
Is this the last page? No, there's another page. 25, 26. Okay. Describe fully the single transformation. Wow, no. Describe fully the single transformation that maps the graph of y equals cos x onto the graph of y equals 3 cos x. Oh, no.
Yes,
This is a kind of a non-calc type of paper.
This would be non-calcy stuff so far, yeah. This would definitely. But
She has the paper.
Oh, you do? Okay, all right. So when it says describing transformations, what is A again?
You know, the amplitude.
Amplitude, yeah. And when we're talking about transformation, so we could say, if it just said, tell us something about changing that graph to that graph, we could say the amplitude changes from 1 to 3. So when they're talking about transformations, what's a transformation-y kind? There's translations, there's rotations, reflections, stretches, yeah. So is this which one of those is that thing going from one to the stretch? Yeah, vertical or horizontal?
Vertical.
Good, yeah. So use those kind of words. We maybe mentioned the amplitude changes from 1 to 3, but because who knows, maybe they're fine with that. But then maybe just try to use transformation-y words. So as you said, it's a vertical stretch.
Scale factor 3.
Oh my gosh, Rose, you're so intelligent.
Thank you, Kelly.
Scale factor 3. If it was a horizontal stretch, so if it was cos x cos 3x, yeah, good. It would be a horizontal stretch of scale factor 1 over 3. This horizontal stretch is the reciprocal. If it was, so that would be if it changed from cos x to cos 3x. Then it would be horizontal stretch of scale factor 1/3. How about that? So no harm in also on top of that saying stuff about the amplitude if you want to, just as a backup. What did you say?
I thought Kelly called math class.
The exam or the?
Yeah. It's exciting.
It's nice when you have all this stuff and it starts to come together. Because a lot of these units are related. So what's cool is you'll get trig questions that have a bit of functions in it. It might even have a bit of logs in it. It's kind of fun when you start to get those combined questions and you're like, oh, I know how to do these. Or I will be able to with a bit of research, like out of this. It is a nice feeling when SL all comes together. So example, sketch a graphy graph. Sketch a graphy graph. Let's add it. Oi. Ah yes, today's And do you notice on what I'm wearing? Because it's our national holiday. It's our national holiday, yeah. It was on the January the 26th. So we get
Oh, happy holiday!
this would be our holiday, our bank holiday.
What is it?
Australia Day. We call it Australia Day. Yeah, it's like your May 24th. But some people
go to Australia.
Yeah, but some people want to move it though because it's like Invasion Day, kind of like Columbus Day in the US.
They were gonna change it to
Right, that's what
so people could be like.
Nice. Yes, they're still desperate. They still want to change it. Like the series talks about changing it because this is a day when it was kind of like colonialization, when like a lot of Aborigines got killed and that kind of thing. So it's a bad day. It's actually a bad day for some people.
To not celebrate, your death.
Yes, to May 8th. And also teachers would be happy because it always falls in the summer holidays. And kids as well, because it's always in the summer holidays when they have a holiday. So they miss out on a holiday. So May 8th would be fantastic because then we'd all get a holiday.
We're upside down right now.
Yeah, summer break. My sister's a teacher and she gets today as a holiday. But that's because you know how there's always a week when teachers are in and no students? Whereas the students are all annoyed because they miss out on a holiday.
What type of teacher is
So they want to move it too. She's a music teacher. Music and ICT.
That's random.
Music and ICT and business. She got forced to teach business.
I have a question.
She did an MBA once and they're like, oh, you can teach business there.
How come when you go to Australia, you don't go from Bermuda to New York to LA, LA to Australia? How come you don't go the other way around? Can you go that way?
What would be the other way?
Instead of going from Bermuda to the right, how come you don't go Bermuda to the left?
It's a good point. Yeah, I think you'd have to go to the UK.
So you can't go the other way?
No, it just doesn't work for some reason. Like it's way faster. It's way slower.
Because you're not against the wind.
Yeah, and I think that's too much of a stretch of ocean, is it? I think the only option is to go up to the UK and then down from there. And I think they
always go up before they go left.
Yeah.
just go up to the UK.
He's right. Bermuda, New York.
LA.
Yeah, that's the way we go.
Hong Kong. And then Chelsea.
But that's the way we go. So that's the direction we all go. I think Krista was meaning the other way.
No, I heard that way.
Oh no, that's the way we go. We go New York, LA, and then on to Australia. Oh no, I thought you were saying why don't we go the other way?
No, so you go to Australia, you go to New York,
Yeah.
and then LA,
Yeah.
and then where?
Straight to Melbourne.
That's
14 to 16
That's
hours.
why you say you go left, right?
Yeah.
So you go. Okay.
I thought you were saying why don't we go the other way?
But you can go the other way if you wanted to, right?
And I think if you do, you have to go up to the UK because I think there's too much of a stretch of water or something. Or I don't know.
No, you go
It's too
left. That's
expensive.
weird. It's like counter.
Oh yeah, because to go the other way would be to go through Africa. And I guess maybe there's, and I think to go the other way you'd have to go through Africa. And I think that there's just not enough flights.
I thought that.
Like there's heaps of flights going the other way.
Aren't you sad that you don't get to go to Australia last summer though?
Oh yeah. Annoying. I might go next
So
year
you take Bermuda
because we get 1 extra day for Christmas break next year, so it might make it worth it. I could fly out Thursday afternoon.
This is next year, like, has to travel. We don't do like travel, so I love the way we're.
Oh, you have the same because remember like there's there's 2 days kind of thing. Whereas they're only making us do 1 trip today next year. But you got your holidays will still be the same. Okay, sorry. So sketch a graph of. Oh yeah, that's a really handy thing to have on the board to explain what we're talking about. Yeah, so you see so Sarah and Felix have noticed there's a map on the wall that would help explain it. So Sarah's just pointing out, so if you went the other way, notice you would go across Africa. Oh, that would be going across Africa. And I think it must be longer. Yeah, normally if you did go that way, it'd be through the UK. So, because there's just not enough flights through Africa. Like you'd have to go to New York, then through Africa, and then across. Whereas most of the time, if you went the other way, you'd have to go up to the UK and then back down again through Asia. And that ends up being longer than going across the US.
Why can't we just go across Africa?
I think there's just not enough flights kind of available. Kind of like there's not enough demand for flights, so the flights are really expensive.
I want to go from Toronto to LA to Hawaii and Hawaii to
Hello. So everybody does be doing this.
And you go to Hawaii, sometimes you should Hawaii.
You not supposed to go that way? International Day Mom.
That's weird. I read somewhere you're not supposed to go that.
Oh, really? So it's longer than it looks.
You know,
Oh, that's annoying. There's no direct.
Oh, she goes.
Sorry.
Yeah, we're
Sorry.
You're not supposed to go this way?
That's the way I go.
That way, to get to America?
No, to get all the way
It's about 10 hours from Japan. I did it once.
Who in this room believes that the world is still flat? I'm standing sideways.
Okay, guys, we've got like 13 minutes. Sorry, I need to finish this. And then you can. Okay, let's finish this so then we can talk. Yeah, if we get through this. Okay, so notes we've just got 2 more to go. One, this and another page. So let's do this so you can have a little bit of questions about the assignment. Okay, so sketch a graph of y equals sin x from negative 2 pi to 2 pi. So just be careful. Notice that the axes, don't sketch it over the whole axes, just do it from where they say. So whatever you do, when they ask you, please, when they ask you to graph between something and something, don't graph outside of it. Just graph from here to here. Yeah. So be aware of that. Like, don't graph outside. If you do, cross it out afterwards or erase it if you have graphed outside of here. They're very strict on graphing just between where you need to. So sketch a graph of y equals sin x. What's its little amplitude? 1, good. So it's amplitude equals 1. Let's write all that stuff out. So the A equals 1. What's its period? B.
360.
Yeah.
So 2 pi.
You're right. B equals 1. So period equals 2 pi over B over 1 equals 2 pi. So it does a full cycle after 2 pi. Is there any horizontal or vertical shift?
No.
Nah, so the principal axis is just the same. So a sine graph, remember, starts if there's no shift.
At 0.
Yeah. Oh.
Classic.
I'm going to have to, I'll just quickly calibrate because I like to show you, I tend to draw points first and then just connect them all up with nice curves. Yeah, it's a bit.
This is
So mark in the little 0 point because that's where a sine graph starts. And then its whole period, it does a full cycle in 2 pi. So try to imagine it would kind of go like this. Here. So it's going to cut again here and here. So it's going to cut here and here and also at the halfway point. It hits a maximum and then it hits the minimum afterwards. So you can kind of do this little bit first. And I'll just put in a boo-boo. So what boo-boo have I just done there?
oh no, I wonder what you did there.
So plus 2 pi. And so all that stuff. I'm gonna put in another boo-boo.
That's wrong.
What did I do wrong?
You put in 2. You didn't even. You went down.
Yeah, it should go down and out. Yeah. Nice. So it should go down and then out, following that cycle. So we'll have a 0 here and a 0 there. And it should go, like you guys were saying, it should go down here and then up to there.
If you let me.
Here's what I do. When you sketch it, don't like sketch it really bad like I just did. Like see how mine went below 1, below -1? They'll be picky on you if you do that. It's just the board's a bit uncolourable.
I just wish that mine was a bit more round.
Mine is great. Mine sucks.
Well, should I put my 2 sticks on far?
Make sure it's nice and curvy. Make it nice and curvy.
I can't like it curvy.
If you don't like the way it looks afterwards, you can kind of erase it. So you can. So it's very curvy and that. Like a line graph.
Miss Ready has laughed.
So it looks like one of those cathode ray oscilloscopes. Pros in physics and stuff. So good. So notice, yeah, we didn't graph outside. So don't graph outside of the dimension.
Promise me. that was really
Don't go outside of the domain. Maybe make a note of that because a lot of people do.
That's part of common sense.
I know. But like,
surprised.
but some people do it. Like when you're marking mocks, you're like, oh my gosh, they grabbed outside the domain. Because sometimes you just. Okay, we've got one more to go. One more. Was it two more? No, two more. Oh no, there's more. Okay, no, there's a fair bit. Guys, let's cut down the chat because I just realised we've got a fair bit. Stop, guys, stop this. Okay, so on the same set of axes above, sketch this one and this one. I forgot we've got to do this and this and the next page. Yes, we do. Okay. Let's do it, guys. Again, later chatting too much, so let's just whip through it. So it's sine again. What's its amplitude? -2. What's its period?
Period is about,
2 pi. It's the same as the other one because b is 1. And what's its horizontal shift?
x over 3, pi over 3.
Yeah, has it shifted left or right?
To the right.
To the right. Good. So I would write shifted pi over 3 units to the right. Here's pi. Pi over 3 would be about a third of the way. So here's pi over 3. So meaning it's now started here. So maybe let's mark in pi over 3. Pi over 3 is there.
Yeah, pi over 3 is full pi over 2.
Yes.
Yeah. It's like a third pi. So it's still the same period. It's still the same. It's still the same stretch. So it's still the same stretch as before. But it's going like horizontally, but it's going up higher each time. So notice this thing got shifted right. This little point will be shifted right pi over 3 as well. So about the same length, pi over 3 up here. But it'll be up at 2 because of the fact the amplitude is now 2. Oh, and it's -2. Oops, my oopsie. It's gone down. So it's gone down to -2. So this thing's shifted across, and it's actually down at -2. About here. Quite hard.
Wait, I'm confused now.
Because it's -2, so it's flipped upside down.
Yeah, I guess that's why.
And it's that point shifted pi over 3 units across.
Yeah.
So this one's now pi over 3 units across.
Okay.
Yeah, that is quite hard. This one's going to be in the same spot, but pi over 3 units over. And then this one's pi over 3 units over, but it's up at 2. I'm going to put that here. I should have got it. I forgot the fact we should be doing.
Do we still have to stay in that domain?
Good point. Yes, you do. That's right. Yeah, let's assume it's still the same. So it'll kind of finish like maybe about here or something. And same with these ones. We've got to do these ones. So pi over 3 units across. So
Wait, it was stretched?
yeah, because it's 2. It's now 2. This one's pi over 3 units across. This one's pi over 3 units across, but down at -2. That's pi over 3 units across. And then from here we'll kind of try to work out how it works. But kind of
Why would it have pi over 3 to sit everything?
Yeah, it's annoying, isn't it? Because pi over 2 would be a lot easier.
Miss Marie, wouldn't we have to go up first, not down first?
No, because it's negative.
It's -2, yeah. The A is -2, so it's flipped upside down. Painful, hey? And then you can probably just continue it on. You can sort of see using the symmetry of the graph, it would kind of connect up to roughly.
So this is 4.
I'll take care of
Me too. I can't even draw it.
It's hard, isn't it? Especially on these boards.
It's dotted line.
Yeah. So that one is, yeah, we'll do this one in red. So just like see the legend that's in red. And then the other one maybe we'll do in purple.
This better not come up on my dog's name.
So what's the amplitude of this one? Yes. What about the principal axis? Guys, principal axis?
Same.
Yeah, good. It's gone up 1. So the principal axis is at 1. If it helps you, feel free to draw in a vague, like, dot, dot, dot principal axis. If sometimes that helps people
That's
a lot.
not 1.
So that's the principal axis through there for this one.
Didn't you say more axis was 1?
Oh, did I? Oh, yeah, sorry, yeah, you're right, yeah. I did that wrong. Sorry.
Hey, Miss Lemon, your graph is a little bit confusing, right? Why is it start curving right there?
We should label our graphs.
Yeah, so at the moment I'm just scared. I would put the equations.
Miss Malolo.
We're not doing that one.
Wait, but for the previous one, why did you start curving way down there?
Oh, no, that's besides the point.
Curving? Oh, because the board's
no, not right there.
not there.
Higher.
Here?
Right there. See how you started curving?
Oh, yeah, so I
It
should
curves way higher than that.
Yeah, I just can't draw it properly. It should be more like that. Right?
Yeah, okay, sorry.
Yeah, I'm just having trouble drawing it. Yeah, so you're right.
That's
That's better. Kind of.
Okay.
And then this one is the amplitude's a half. The principal axis has been shifted up to 1, like you said. Has there been any horizontal shift?
Yeah.
No. But what about the period? What's the period?
2x.
2x.
Does it 180 or 720?
Yeah, 2 pi over 2, so it's pi. Yeah, 180 degrees. Yeah. So it does a full cycle from here to here. So that's interesting, isn't it? So it's done a full cycle from there to there. So it goes up by a half and then goes down by a half. So it's a plus a half, yeah. So
Oh, it starts at 1. Okay, yes.
but it's positive a half, so it goes up first. And there's no horizontal shift, so it goes from kind of the y-axis, and then it'll do the same kind of pattern again. So drawing one little cycle there sort of helps to sort of see the pattern. Yeah, so it's hard, isn't it? It's all very quick changing.
I like this one a lot better.
Me too. I think that I draw a better graph when I don't draw in the points.
Okay, good, that's done. And I would like the equations if you can, but because my graph is so messy anyway, I'll just color code it.
Oh, I can't keep doing it.
So that could happen in an exam. They can make you do multiple things on one set of axes. And...
That is the hardest for them. Why would that?
Okay, we can do the next one next lesson because 10 takes a bit. Fiddly, isn't it? Yeah, ask away, yeah. No worries, see you later. And who am I seeing today? Period 3. And who am I seeing period 5 on Wednesday? See you, Owen. Bella, yeah. Oh, and how's yours going? Send it to me tonight. And you've done the little pictures that I said, or the pictures. Yeah, good idea. Send it tonight. Tonight's fine. Like harassing people. Where's Bella gone? She doesn't run it. Where's that Bella? Where's that Bella?
I think she just wants to put her stuff away.
Oh, there she is. How did she leave? Oh, yeah. So now I've got to remember how that whole thing worked. I think it's just gone from my head.
Oh no.
I wrote it down
I don't know
somewhere.
how to do it.
It's in there. Oh, but I know what I've done is I've highlighted the pages.
Okay.
So you can have to look at. Yeah, I try to find is there any reasons why architecturally they don't tend to do octahedral ones, and I couldn't see
I
anything.
think it might just be easier, just thinking about the amount of rods you would need. It's probably easier to do the log ones.
So I'm just gonna add.
Oh, that's yours. Okay.
So I have to add a bit more to this, to that bit because I haven't. I've worked
Flesh it out a
on
bit,
that.
yeah. And in your intro, you always talk about what maths you're going to do and why, like what it tells you. So I'm going to do some graphs. I'm going to make some
Oh,
static
with
graphs.
hindsight, because the way I've.
Oh, and you say this if you haven't done it yet.
Okay.
Yeah.
As if you haven't done it.
Yeah.
But
I will do
the way
this. I will do
The
that.
way I've structured my essay is that I've said. So I did the raw data. Is that okay? Obviously, I
It's
put it on
fine, yeah.
different
Some
pages.
people put in their appendices. Some people have it at the beginning.
Okay, then
But your tables are nice and small, so.
Then I
the
said
beginning's fine.
the graph about should.
Oh, and whenever a table runs onto the next page,
I was just.
yeah, and you'll snip that and just pop it there. Yeah, but I know what you mean. Like when you.
I'm just gonna because I'm not worried about pages or anything, but Is that a okay thing to talk about? Because I remember you said you had, because this is a graph of rate
Yeah.
diabetes.
But to start with, you should have just the graph without the model. So this should be the, I'll write a note for you.
Oh, but that's
So
just
this
the
should-
one to show that there's a relationship between.
Nah, there should be no model to start with.
No model to start with.
This should be just a scatter graph with no models. And then this stuff comes later.
No.
Yeah.
The rate of obesity. What do you talk about it? What do you call
With
it?
no models or etc. You just talk about, like, imagine nothing's there. So that thing could still go with that. And then,
Don't talk about
yeah, this stuff should come later.
later.
Yeah. So here you should just be talking about the visual, what you see visually.
Okay, then I guess
And-
this tells us that the relationship between obesity is strong enough to continue modeling. Because I'm trying to say that because I remember you said.
Oh, that doesn't justify why you're modeling. In a way, like, this is more an afterthought. This section's more an afterthought. Your modeling's your big thing.
So when would you put that, like, at the end?
An afterthought kind of thing, yeah.
Okay.
You could say an afterthought, my afterthought is, if I had more time, I could look into the relationship between obesity and stuff. And take this further. Yeah, just chuck that in as an afterthought.
So then I said the following two graphs show the rate of diabetes and the rate of obesity, the excesses were changed. And
See, that's nice, yeah. See how you did that before.
okay, is that like, because I don't know how I'm supposed to be commenting on it.
So now this, by the way, this will be graph one, so be careful of all that.
Yeah.
That'll be the new thing. And then graph the rate of diabetes and rate of obesity. Oh, in a way, that and that is not those two graphs. So just be careful to say the graph below shows the rate. Just stick with what this graph is,
Yeah.
and then here talk about what that graph is.
Okay.
Talk only about this graph.
Like immediately in front.
Yeah, just for structure.
Okay, yeah, because I'm a bit
Then talk about
confused
this
about
graph.
structure.
Yeah.
But I just also want to know, like, how to comment on things, because basically what
How
I've
to
done,
waffle on, yeah.
like, because I don't know how to do the conclusion, right? Like, I know how to do my error analysis, I just don't know how to write it out.
In the USA.
Yeah.
Yeah, like be really thorough with all that stuff. Exercise values were changed to years since 1995. Maybe make that as
I didn't know
like as a
how. Years.
like
Does it say?
because here it doesn't. It's not obviously you're talking about a title
Okay,
of
so
an axis. Yeah, so maybe put in quotation marks and
Okay,
make that
quotation
capital. Yeah, it's easier to analyze mathematically with numbers ranging from 0 to 20.
does that make sense? Because I didn't know how to word it.
Yeah, that makes sense. Yeah,
Okay.
that does. Yeah. USA from rate of diabetes. Is it percents or something?
Yeah, should I put that in the title?
Yeah, always give exact full data title, like data title from the source. So if they say rate of diabetes in 550 US states for the year,
Alright, should I do percent rate?
yeah, like more
Yeah.
detailed, way more like as detailed as it was when you got it from the source.
So, but if I just add percent rate of diabetes in the USA, that's fine.
No, it has to be the full, like whatever the source.
Okay,
called it,
okay.
You've got to call it that kind of thing.
And then is this a good comment? Because I don't know how I'm
The
commenting.
data points in graph 2. That's a trend for the data part points, yeah. Looks logarithmic. Shape of the trend for the data points in graph 2 looks quite logarithmic due to the gradual growth in rate of diabetes from 0 to 20 years. Oh, no. Logarithmics
Yeah, I don't know
go
how
up
to.
fast and then slow down.
Okay, so talk about. Okay, I was talking about this would be the end bit, and I was saying how there was a spike in the 1970s, so that would be like the asymptotic point. Because I just don't know how to describe it. How would you?
A logarithmic graph goes up
You get
fast and then the rate of growth gets slower and slower until it starts to approach a common value.
So how would you comment on that? Just to say
How would you say
it looks
because I can't tell you the
No,
exact
I know.
words to use. Yeah, you say something and I'll tell you how to fix it. Oh, you
okay. The shape of the trend for the data points looks quite logarithmic due to because it looks it looks